Okay, today we're talking about concentration. And so with concentration, there are a couple different things we can look at and we can use. So at the end of this video, hopefully you'll be able to identify various means for calculating concentration. You'll be able to use the molarity equation to calculate the molarity of solutions. Along with, we'll look at mass percent, we'll look at molality to go along with that. So here we go. So to start with, concentration is, when we say the word concentration, we are looking at how much solute is dissolved in a solvent. So because we're talking a solution, we're talking about a solute, which is the substance in lesser quantity, dissolved in a solvent, which is a substance in greater quantity, and I want to know how much I have dissolved in there. That's what we're talking about with concentration. So we're going to look at a couple different things. We'll look at mass percent, we'll look at molarity, we'll look at molality. They're very close but slightly different, and we'll look at mole fraction. In this course specifically, we are going to use molarity a lot. That's going to be a very important calculation for you to be able to do and concept for you to understand. To start with, though, we're going to talk mass percent. So mass percent, to calculate mass percent, we're looking at the mass of solute in grams divided by your mass of solution, also in grams. The grams is kind of arbitrary. It can be milligrams of both. It can be kilograms of both. They just have to be the same, because when you cancel them out, you're going to be left with your percentage. So think of it as your mass of solute is the number of questions you got right on the test. How many did I get right? How many was I supposed to get? How many was available? Mass of solution. And then it gives us a percentage as a decimal if we take it, or that will give us our answer as a percentage. Take it times 100, you get your answer. If we're looking for how much solute, if I want you to tell me how much solute I had, based on the percentage and my grams of solution, I can multiply those two and I can get my answer here. So that is mass percent. Here's a practice question I'll walk through with you. So this one, a solution is made by mixing 30 grams of ethanol with 100 grams of water. What is the percent by mass of ethanol in the solution? So because I only have 30 grams of ethanol here, and I have 100 grams of water here, the one in lesser quantity is my solute. That's going to be my ethanol. So I know that my mass percent is equal to my mass of solute divided by my mass of solution. In this case, my solute had a mass of, we said, 30 grams. This is going to be 30.0 grams of ethanol, divided by mass of my solution. So this is not solvent, this is not just water, it's solute plus solvent is my solution. So it's going to be plus, or it's going to be over 100.0 grams plus 30.0 grams. So that's going to be equal to 30.0 divided by 130.0. This is grams, also over grams. And if I take 30 divided by 130, I'm going to get 0.23076. And so to do this, I would tell you to do two decimal places on a percentage. But so we're going to take this times 100 because we have to get it to percent. So take that times 100. It's going to be equal to 23.08% ethanol in this solution. So you calculate the percent of ethanol in that solution, which is 23.08%. Here's another one for you to try. So 146 gram sample of seawater is evaporated, so only 5.2 grams of solid residue remains. What is the mass percent of solute in the original seawater? So you have your solute, and you have a solvent, or a solution, and you can figure out your answer from there. Okay, molarity. I told you this is the one we need to know, especially for this course. Molarity is the number of moles of solute dissolved in 1 liter of solution. Okay, so we're looking at moles of solute. Oops. Molarity is equal to moles of solute divided by liters of solution, which is going to give you units of moles per liter, which we designate as a capital M. So this M indicates molarity. This M, because it's moles per liter, means molar. This is the M that goes after your number. So molarity equals moles divided by N over V, which is moles divided by volume. Again, N is moles, and so to find moles, you have to take the mass of your solute times your molar mass. And that's our mole conversion, which we've done already. And so that's going to be there, which is why that's really important. A way we can manipulate this formula. So we know that molarity is equal to moles over volume. We also know that moles are equal to the grams of solute divided by the molar mass. So this equation, molarity, is equal to, if I substitute all of this up here, I get M equals grams divided by volume times molar mass. All of that, I guess those two are multiplied together. So grams divided by volume divided by molar mass. And so I can rearrange that, and I can solve this all for grams. And I can take volume and molar mass to the other side, so I end up with grams, or mass, is equal to your molarity times your volume times your molar mass. And this is just manipulating that original equation of M equals N over V and solving for grams, which is part of N. But this one you'll probably use a lot, but you need to be able to get there and not just memorize it, because you're going to forget the molarity equation to go with it. So if you know this equation, M equals N over V, you can get to the rest of it, which is what we want. Practice example. So what is the mass of solute needed to prepare 8.45 milliliters of a 0.437 molar solution of KCl, which is potassium chloride? So first thing you should do, I always encourage you to do, is write down what you know. So a couple things you will know is grams. You'll know the mass. We can know molar mass. We can know molarity. And we can know volume. So based on this question, we know the volume is 0.437 molar. We know that my molarity, no, I lied. Scratch that. Scratch that. That's not my volume. My volume is 8.45 milliliters. My molarity is 0.437 molar. I'm looking for my mass, and then I can go to my periodic table and get my molar mass. Okay, Google, what's the molar mass of potassium chloride?
The molar mass of potassium chloride is 74.55 grams per mole.
According to Google, the molar mass of potassium chloride is 74.55 grams per mole. I don't have my periodic table with me, so we cheated. So I know my molar mass, I know my molarity, and I know my volume. Remember, molarity is equal to moles per liter, which means that this needs to be converted to liters. So we got to go from milliliters into liters. So remember, milli is 10 to the minus 3. So that means I need to move my decimal place 3 to the left. So I have 0.00845 liters. So now I know I have a molar mass of 74.55 grams per mole. I have a molarity of 4.37 molar, or moles per liter, and I have a volume of 0.00845 liters. In my original equation, molarity equals moles over volume. I know that N equals grams over molar mass, abbreviated MM. And so I can substitute that in here, so I can get M equals grams, or mass, over volume times molar mass. And I can solve this all for G. I'm going to multiply these all across. So my end equation is going to be grams, or mass. I should write mass instead of grams. Is mass equals molarity, or big M, times volume, because we took that across from the bottom, times your molar mass of your substance. Knowing that, I'm going to come down here now, because I'm running out of space to write. So my mass is equal to my molarity, which was 0.437 molar, times my volume, which was 0.00845 liters. Really struggling with my force today. Times my molar mass, which is 74.55 grams per mole. If I multiply all of those together, I did 0.437 times 0.00845 times 74.55 grams per mole equals, I should get a final answer of my mass is equal to 0.27529 grams. And then I need to go back, and how many significant digits do I need? I had 3 up here in this number, and I had 3 in this number, so my answer needs to also have 3. So this is going to be equal to 0.275 grams of KCl. And that is going to be your answer for molarity there. Here's another question you can answer. This is molarity of a solution. You can solve that one. And then you can get those answers as well. And that kind of walks you through it step by step. You can work through those on your own. And then this is another example. I'm going to stop this video here. I'm going to make another video for molality and mole fraction. So I will stop this one at this point, and we'll pick up here on the next video.